All right, we're good to go? All right. Well, thanks for spending your time with me today. I'm very excited to be here. My name's Randy Bias. I'm going to talk to you a little bit about AI agents and operations, something I know a little bit about. But before we get into it, just a couple of quick notes. I've got this little pet peeve, which is there's this term vibe coding, which is turned into vibe ops and vibe marketing, and everybody's vibing. And I just want to say, from my perspective, this is a vibe. This is not a vibe. This is a vibe. And we're moving more towards spec coding, so it's even less vibey. All right, so let's get into it. So who am I? I don't want to regale you with like my history and all those kinds of things. I'd rather tell you some stories. The best way to find out more about me is to go on LinkedIn and check out my biography and background. So in 1990, I started in Silicon Valley as a system administrator. And, when I walked in, I was kind of shocked because everybody was manually editing all the configuration files on the servers. And I was like, why would you do that? The computer can do that for you. So the first thing I did was I automated the hell out of the entire system so that when a new server came in, we made a few database changes, pressed a button, and the entire fleet of servers was completely reconfigured for that new server. 30 minutes. That's 1990. There's no DevOps. Open source is nascent. There's no automation tools. I had to hand build the whole thing, right? So that's that. I took that with me. So when I went into network engineering in 93, 94, we're in an ISP. There's no automation tools for networking. So I built all the automation tools to basically automate the provisioning and deployment of our networking systems, our routers for our points of presence and so on. And I did that again and again and again and again throughout my entire career. And so imagine kind of how it was for me when AI, which I was initially a skeptic of, came out and I started playing with it. And I was like, this is the Uber automation tool, right? I can do so much with this. And I'm still learning every day. And so I kind of want to talk about ops and automation. So what's interesting about what's happened is that software development is a first order citizen in kind of AI agent land, right? Everybody here is using Cloud Code or Cursor or something like that. And the entire system is set up for developers, right? Operators, it's not really set up for. They still have pretty crude tooling. People are playing in different areas, but it's, night and day. And the use case isn't really the same either, right? When you're a developer, you're building, right? You build, and then you ship it, right? And a lot of the times now you ship it, and who do you ship it to? You ship it to the operations guy who does the maintenance on the system. And so that whole holy grail of DevOps, we're going to fold developers and operators together, never happened. SREs, that's a whole other bucket, right? It's not quite the same thing. But the reality is that software development and IT operations are fundamentally different disciplines. So we're very familiar with this kind of workflow, right? This is the workflow we see all the time right now, which is that the developer drives kind of an agent through prompts, builds software, has the agent implement the plan. More and more the developer is becoming kind of the puppeteer, person who creates the specifications, and the agent basically follows through on that. Well, in operations, we do a similar thing, right? We're rolling out new code, we're doing an upgrade or an update, doing some kind of maintenance, we can drive the tool. I use Cloud Code every day to drive Kubernetes. Kubernetes has sharp edges. Cloud Code makes them all go away. There are other models though, right? There's other workflows, right? So one of them is predictive ops, what I call predictive ops, which means that on some kind of interval, cron jobs, some other kind of interval, you're doing things like capacity management, trend analysis. You're basically predicting what's going to happen in the future in the system to try to avoid problems. Then there's yet another, which is reactive operations, which is what we're going to talk about today, which is that something happens in the system, and then you have to take action. There's a failure, there's an event, something happens, something goes down. Now, we all hope that our systems don't fail, but we all know that they do. And so when that happens, now what you have is you have the infrastructure or applications actually driving the agents, hopefully. That's the model I think we need to get to, rather than a human. So when I first built this proof of concept that I'm going to show you, and when I first came up with this deck, OpenClaw did not exist. And so OpenClaw does have some of these notions around kind of what I call workflows that are very similar to reactive ops or predictive ops. And we'll talk about that at the very end, just briefly. Okay, so what does it look like? So it was Christmas time, and I had less to do. Everybody's off. It's easy to basically write a lot of code really fast now. And so I decided, hey, I'm going to go figure out kind of an infrastructure, application-driven, agentic workflow. So I want the infrastructure to basically trigger some kind of event, have the agent respond to it, and do what the agents are good at. All right, so the whole idea was to also sort of try to see if we could exercise the model context protocol in certain ways that it's not being exercised. So if you go and you read the actual spec, there are things in there that aren't really talked about. One of them is the notion of events. So you can take an MCP server and you can emit events. And what that means is you make a connection, streaming HTTP, you hold the connection open, and then the server can send you an event. It's right there in the protocol. Nobody uses it. Nobody uses that part of the protocol whatsoever. But I said, that's exactly what I need, right? So what I wanted to do was build a system where an MCP server would basically emit those events based off of faults in Kubernetes clusters. So something like Cloud Code doesn't handle this well. If you use Claude or any of the other agents that want to make a tool call to MCP server, take it back, and then make an LLM call. That's what they do. They don't want to hold open a socket and wait, although it's getting better. All right. So what does it look like? So the idea is that we would have a set of Kubernetes clusters, each with their own API, of course, but also an MCP server. The MCP servers that I could find out there for Kubernetes did not have support for events, so I had to add that support. Thank you, Cloud Code. That was easy. And then I have a series of event listeners that are sitting there, holding open a streaming HTTP connection to the MCP server on all those Kubernetes clusters and waiting for those events to fire. An incident handler that when it gets those events, basically processes them. Sorry, too much coffee today, or too little, I'm not sure which. Tracks their state through an incidents database, and then runs triage agents to basically connect to those Kubernetes clusters and do a full triage run. So talk to the Kubernetes cluster, find out what's going wrong. Now, these triage agents are Cloud Code, Gemini, Codex, and Goose. They're all interchangeable, right? So part of my objective was also to show that you could use a general purpose agent. Because one of the things I see right now is this transition from people building customized agents to using general purpose agents with a combination of skills and tools that make them domain experts. So the triage agents, when they're finished with the triage run, store the report into Object Store and then send a notification to Slack. So your operations team gets a notification that an event happened. Basically, there's some kind of failure in a Kubernetes cluster. They get the report, they can read through it. There's a proof of work that says what the agent did to basically do that investigation, what its root cause analysis was, recommend a set of next steps, and then the operator can make a decision about what to do. So I talked about this, and I'll talk about it in just a little bit more detail in a second, but the idea was you have to have those events come from Kubernetes, but Kubernetes has lots and lots of events. So there had to be some kind of pre-qualifier or filter to basically determine that it was an event that was worthy of doing triage. So I had to modify Kubernetes MCP server to send the events and to basically have that pre-qualifier or filter. I had to build the core of Nightcrawler, like I said, all general purpose agents to receive the faults. Then they run the triage agent, and I thought to myself when I was doing the design, I don't want 10 or 100 agents all pounding on a Kubernetes cluster, all trying to do triage at the same time. So kind of single-threaded triage to a single cluster, but then you could parallelize that as much as you want to, run it to N. I built a Kubernetes troubleshooter skill for basically any agent to run and use to basically help them. And the key there was to create a structure for the report so that the report was deterministic, because we all know that agents are non-deterministic. So what we need to do is we need to say, here's the structure of the report, generate this completely in Markdown, follow these rules, follow these steps, and so on. Also, the Kubernetes troubleshooter skill had a whole triage process written out in it. Do this, and then do this, then do this, then do this, and here are these optional things that you could do. So it could follow the script. And so something here that I didn't get to, but I really wanted to, was to have skills for troubleshooting AWS, Azure, OpenStack, VMware, the underlying infrastructure. But maybe we'll do that in the future. So you probably can't see this very easily, but I'll just walk you through it real quick. I know I'm going quickly, but I want to make sure I've got time for all your questions. So again, Kubernetes cluster, it's doing its thing. Events are happening. You've got this qualifier filter. It matches on certain kinds of events and not others. And when it does, it triggers the MCP server to send the event, basically to emit the event. And then that's picked up by the MCP listener. Incident handler grabs it, puts the incident information in the database so it can track it to end of the triage run, runs the triage agent through the agent runner. It does its whole process, running general purpose agent, generates a report, sticks it into object storage, and then goes back and sends a Slack notification, updates the database. So one of the interesting things about this is that this workflow is actually general purpose. This doesn't have to be triage, it could be something else, right? All you would have to do is actually change out the skills or the tools. The important thing about this is that it is the infrastructure, it's Kubernetes triggering the agent to run as opposed to a human. Oops, I guess I've got a duplicate slide, my bad. Okay, just look at this really quickly. This is an example of the triage agent report. Like I said, by taking the skill and being very careful and being very clear with the agent about the format, I could get a very deterministic report every time. And what was interesting was, even though I sort of started by using Opus and kind of, GPT 5.2 at that time, I found that once the skill was tuned well enough and the report was clear enough, that I could drop it back down to Haiku or even GPT 4.1 and get pretty good results. Once you got to 4.0, it got really bad, right? Or older versions of Haiku, 3.5, 3.7, it was just garbage, right? But one of the things that really stuck with me, I saw an interview with the CEO of Replit. He basically said they do just good enough, when they're building a new kind of tool and it's a little janky, and then 6 months later, a model comes out, a new model comes out, and that tool suddenly works. So we're kind of on this crazy curve, and we're all riding it together. But it's just something to keep in mind. Like, it doesn't have to be the highest end model that you run. You can use the skill to really kind of put the agent in a box. And the important thing about that is that then you can use the lower cost models, right? And if you're going to be running triage runs all the time, that's important. This is an example of the Slack notification that it sends, where it would have basically a button you could click. But you could imagine doing some cooler stuff here, where in the actual Slack channel, you could do a reply to the agent, and you could say, hey, rerun that triage run and do these things. And you could add on some pieces, or you could ask it to do some additional investigation. So one of the things I kind of skipped over is that one of the artifacts that comes out of the triage run is a complete snapshot of what the agent did. It's got a proof of work. It says all the tool calls that it ran. It says it has all the data that it picked up and gathered about pods and namespaces and all that good stuff. And it's also got a full snapshot of the session, right? So Claude Code, for example, saves your sessions under .claude in your home directory. And so you can save that, and you could restore that on a secondary run based off of somebody saying something in Slack, and it would restore the session, and it would resume from there with the additional instructions. So you could see this kind of asynchronous kind of model where operators could basically drive the agents after the event was kicked off from the infrastructure. I had to have some kind of admin UI. I'm not a UI guy, right? But again, thank you, Claude Code. It cranked out a great admin UI for me so I could see the clusters that were being monitored and see the actual runs. And then, just for giggles, because it's so easy, I wanted to see every time that the agent, during its investigation, what it was doing. So I went in and I used the pre-tool use hook in Claude Code to basically send a message via NATS about what it was about to execute. So in the admin UI, you can actually see it updating. And that way, in case anything hung in the triage run, I could see where it hung and where the agent got caught up. Okay, so where could this be taken? Again, like I said, I have this kind of vision that I'm still trying to, kind of wrap my head around where it goes, but I can imagine a scenario where you've got the skills and the tools to troubleshoot all the infrastructure, but more importantly, you've got this framework where you could allow operators to start to do things like create skills for their specific applications. Because if you go into, say, Visa or eBay or any kind of technology company, their operations folks are more keyed in about how their application works. My buddy Paul, he used to run the NOC at eBay. And when I went in and I saw the NOC at eBay, there was absolutely nothing on the monitors about storage or networking or clusters or anything. It was all about API endpoints, transactions per section, transactions per second, and so on. So it was really about how is the application running. And the only experts for your application are your team who manage the application. So you can imagine making a set of skills for each business so that a triage agent would actually understand how the application's supposed to run, how it's supposed to operate, how the middle layer is supposed to operate, Kubernetes and all the supporting pieces, and how the underlying infrastructure is able to operate, and it can troubleshoot it end to end. So just a couple of quick things here since I've still got time. You could, right now, the way I set it up was I wanted to make sure that the triage agent was read-only. I'm a longtime operations guy. I'm not really comfortable with agents running crazy in my systems, but the idea of doing triage is pretty easy. If I give it a kubeconfig credential that's basically read-only, it can do whatever it wants, go to town. But it was all kind of done manually. You could imagine having an MCP server that would actually, when it emitted the events, would emit like a read-only time-bound and scoped credential to the agent to do the triage run. So it's able to do that triage run for the next 15 or 30 minutes or whatever. So you can start to add in some trust and some security measures to basically make it more secure. And I did skip over that part. Like the triage agents all run as Kubernetes jobs in basically a sandbox Docker instance, which is basically hardened, and all the tools and tool chain is pulled out so that it makes it very difficult for anybody to do some kind of prompt injection and break out of that container. Okay, so again, I mentioned this, but I just want to reinforce it because I think it's important. This is the right workflow, I think. You could modify the workflow and tweak it a bit, but the idea of it being kind of initiated from the infrastructure or application side is important. But you can imagine a lot of other things that you could do with this. It could be a run to do, optimization. You could see that basically transactions per second are lower during a certain period of time of the day, and you want to do a run to see what that does to system resources. So you can, have a pipeline that's feeding into, how you're going to do capacity management and resource planning. And so again, all you would need to do is change the agent skills, add additional tools, change the prompt, right? There's a custom prompt in here, and effectively, this goes to my larger point that I've been making on LinkedIn a lot, which is that you could take these general purpose agents and you can make them experts in these domains by giving them domain skills and domain tools. So just a quick word on OpenClaw, CloudBot. Everybody knows what that is by now, right? So until that came out a few weeks ago and really got a lot of traction, and I have not played with it yet, but until that came out, I think most people were on that kind of like, proactive model where it's me driving the agent, telling it what to do. CloudBot has provided the average person more of those kinds of additional type of workflows, right? You can run cron jobs on it. They're a little limited, but you can do it. And it's got sort of a little bit more, it's acting more autonomously on your behalf, right? So it kind of addresses some of these issues. Now, obviously, there are security concerns with OpenClaw. I haven't run it. I'm not comfortable running it, so I haven't run it. But I have taken NanoClaw out for a drive and NanoBot, and those are getting closer to those ideals that I have, especially NanoClaw, where it's basically said, hey, this is OpenClaw with everything stripped out, and when you want to add to it, you just add skills and build it up. And so I look at that, and I'm like, well, that'd be interesting if you built an operations-focused NanoClaw that could be the semi-autonomous agent that helps the operations team, and you just build out the skills from, first principles where you're only adding skills that you need, and you're doing it in such a way that you can do it in a secure way with a high level of confidence. Okay, so just to wrap this up, which will give us lots of time for questions, which is great. The developer workflow is not the only workflow. And I think people will discover more workflows in the future, but we have to do that in order to make these things be more effective for us. And I always think it's interesting because there's this intent, and people talk about long-running agents a lot, to sort of like figure out how to have, unlimited or infinite context windows and so on. And that's one way of solving the problem. Another way of solving the problem is just scoping it down. When I was running engineering teams and my own startups, I always said to the team, I said, one way to just like reduce, or one way to fix problems is just reduce scope and not have to deal with certain problems. Like they're just out of scope. It's not part of the system. So that's a great reason why these kind of short run ephemeral agents that basically do this triage, it's clean. You can keep it really clean. You can keep it very secure. You can keep it very deterministic, but still leverage the benefits of the agents to do the triage, to give you a report, and so on. So I think that's most of the good stuff. I've got 8 minutes to take questions. Oh, we're so organized. This is a small meetup, but it's so organized. Great.
Yes, hello. I have a question. Do you see like Claude or other models performing badly on some parts of the infrastructure, so they don't understand some very niche topic about like Kubernetes or specific business niche topic, even like with the skills? Or they actually like good enough, like from vanilla Claude Opus 4.6 to do like at least a triage? So is there like a gap in their understanding how the ops works?
Yeah, so what I like to say to my coworkers is I'm still having a hard time finding something that Claude can't do. So, I keep throwing it at things and it keeps exceeding my expectations. But the times where it's something new, I'll give you an example. So Mirantis has a kind of like a super control plane, Kubernetes for managing other Kubernetes, right? All based off of CAPI and stuff like that. And Cordant is new. So, it wasn't trained on, it doesn't have the level of docs that Kubernetes does. But, how I solved it was I said, go read the docs. And it went and read the docs, and there was no problems after that. I had it upgrade one of my tools from deploying 1.40 Cordant to 1.70, and I didn't have to do anything. I just, really spec'd it out clearly. It went and read all the docs. I figured it all out, tested it end to end, did all the work, came back, I verified it, done.
What is that you're currently missing the most to move beyond the triage and go to the next level where you have the fixing layer that based on the triage would be firing commands on the clusters to kill the service, scale up, and how to go even deeper where actually based on the observability, you won't be fixing the effects, but the causes, for instance, shitty code, right?
Yeah, so there's a few things in there. So first of all, like I said, this is a proof of concept. I was just trying to prove out the workflow. That's number one. But you can see where this is at, where I'm providing a Slack notification that basically says, that's got a single button that says view the report, right? But I could just as easily send a Slack notification that had view report, take remediation actions, or something else, right? There could be a variety of buttons in that report. So if the report says, here's the suggested 3 remediation steps, I could dynamically put 3 buttons for each remediation step in there, and then you could have an operator view the triage report, make a determination about what the right action was, and then press the right button, and then trigger a different agent to basically go do that run, to do that remediation. I don't think most operations teams are ready for that yet, and I'm not sure how we get to that, because I personally would be nervous. But I think it'll be a stepwise change where it'll be like you'll go and you'll have basically a tool that'll do specific remediation steps that'll be deterministic normal code, but then you could have kind of an agent watching and looking for failures. You could also have an agent watching deployments of new code to see what happened. And to kind of the last piece there, in my experience, Kubernetes handles almost everything, except when it doesn't. And for the span of my entire career, the number one cause of failures has been people. And number 2 has been bugs in firmware, hardware, and software. And those things are just not going to be easily solved. You're going to need a human basically to be involved. And, we'll get better and better over time. But again, my big point is I don't think these agentic tools are being deployed and in operations and being used in operations so that we can develop new techniques and new ways of using them, right? I mean, that's the whole thing, right? Like people are figuring out how to do software development in whole new ways, but operations is still doing everything the way it's always been doing it.
And if I may, you've mentioned that everything for the audit purposes has to be documented. That sounds to me that keeping the track and logs of all the agent activities may create in the long run huge amount of the data to be analyzed, because the human actions usually create small trail. Like I did something, it's documented, sometimes it's not.
Yeah.
With the agentic work, especially to understand if the agent did screw up, where it did, I'm thinking that the amount of the data that will be generated for it will be just immense, and how to handle that in the long run.
It would be, but the reality is that you only need it for a certain period of time, right? So there's a way to age it out. So I don't think that's a big problem. And storage systems are large and cheap, and there's compression and dedupe and all kinds of things that we can do. So I don't think that's really a problem.
Thank you for this presentation. I just wanted your opinion on if we continue to have these agents that act autonomously and there's a human, not really a human in the loop as much, then from the regards of like observability, people will start to just trust like the AI agent, even though they don't know exactly where did this information come from, and that can lead to problems later on. So I'm curious, like, what is your perspective on this as we continue to automate things and take humans out of the loop?
Yeah, it's funny because I think that as people get more and more dopamine hits, they're more and more tend to want to trust what's going on. I'm just as guilty of anybody else of going like, hey, that looks good. And then sometimes I regret my decision and I have to wind back the code. But, the reality is that I think that if we kind of extrapolate out from, kind of what went before, and this is me kind of going a little bit crazy here, but in the cloud days, I spent a lot of time speaking at conferences and sort of talking about kind of the new way, which the pets versus cattle thing, which was kind of my thing. And, a big part of that was this idea that, a lot of the infrastructure and components and even, application instances could just be thrown away. I think we're entering this era where you can just throw away code and you can, start to think about building models that are more organic, in that you can almost be A/B testing your systems and running different kinds of code in different places. And if you start to realize that, one is bug ridden, kind of start to throw it out. And that's just me kind of, pontificating a little bit. I'm not sure what that exactly looks like, but I suspect that the way that we do operations and the level of concern that we have over bugs or even human failures is going to change dramatically in the next 10 to 20 years.
Thanks.
38 seconds.
Yes, one short question.
So we have something similar in my company, and there is a lot of red herrings that show up.
Yeah.
Because of some sort of negligible errors, like that are logged, or like they don't cause a production problem, but they nevertheless show up everywhere. How do you approach this?
Yeah, so the way I did it with this system, again, this is a proof of concept, right? I wouldn't put this in production, is that basically the system, looks and waits for things to resolve themselves, because a lot of things do in Kubernetes. And then it assumes that an operator saw the report, and that if it's not resolved within a certain period of time, that it's just a non-issue. So letting basically, you're dealing with the signal and noise ratio, just letting the noise kind of be noise and ignoring it. I'm not sure that's the best approach. I think it would be better to start thinking about ways that we could deploy pre-filtering systems based off of lightweight agents basically in cluster, or like, where the MCP server is. Right now I've got a very simple qualifier filter, but you could do kind of almost an early stage step where you're using a lighter weight model that's relatively inexpensive that you could run very frequently to do kind of that pre-triage almost, to basically increase the signal to noise ratio. But we're never going to have a perfect signal. You're always going to have some amount of noise. It's just the way that systems are built.
Thank you for the presentation.
Thank you.